being on YouTube for venting at the end of the day. So very quickly, we're going to go through the equipment itself. It is air-operated equipment, so you connect an air hose to drive it. The basic functioning piece inside we call a ZEVAC core. The core consists of an air drive piston that reciprocates the gas suction and discharge pistons, which in turn transfer the gas. The footprint of this equipment, it's really intended to be a tool. This equipment will fit in a pickup truck. You can pull pressure all the way to 0. There's not a low suction limit unless you choose to set it. And these cores can be packaged in a scalable way. We can package 2, 3, 4, and so on together to address bigger and bigger lines. The equipment's completely mechanical. There's no electronics. There's no batteries. There's no spark creating entity. Everything is air driven and controlled and mechanical. So you can use this equipment in places with active gas. So we don't have to have ATEX, or you can take this into a class 1 Div 1. This is all mechanical and pneumatic equipment. There's high and low pressure auto shutoffs, so you can set the machines to shut off when the drawdown reaches a certain point. You can set the machine to shut off if the discharge pressure ever rises to a certain point. But fundamentally, the machines can sense the back pressure against them. So in our trap launcher video, the machine can sense the back pressure, the line pressure that it's pumping into, and it only rises to meet that pressure and push in through a check valve. So unlike CNG or bottles where you have a very high pressure source that you then have to be very careful about metering in, here we only create the pressure that we're transferring into. We don't create very high pressure and then meter in. When you look at a machine that's in the back of the truck, what you're going to see is an air connection, an air valve on the left, a gas connection for the discharge hose, a gas connection for the drawdown hose, and then up at the top are your gauges. So this equipment is very simple to operate. We try to make this as user-friendly as possible for the technicians in the field to put it in the back of their truck, go to work, and transfer gas instead of vent it. This isn't something with complex control panel or programming or sensors and a bunch of things that can go wrong. There's an on-off button and 2 gas hoses. So we really try to focus on a very simple to use machine that's easy to tote around and go to work with. Inside, this is that core. So in real life, if you open the box, what you'll see is 1 or 2 or 4 of these cores that consist of the pneumatic drive in the middle and the gas compression transfer components on the outside. So as we look at different applications, be it curb T to house, that might warrant, it's a very small volume. 1 ZEVAC core in a solo machine is all you need, all the way up to multiple quad core machines working in tandem. The picture here is a quad machine. As you see, there's it's too high, and then it's also too deep inside the box. So you actually have 4 cores running inside this machine. And this equipment is built in 3 different models. What we call our D model is intended for distribution systems. It can create and overcome up to 200 pounds of differential. So if you operate this on any line under 200 pounds, you can pull it all the way to 0 before the machine will stall. if you connect that D machine to a 270-pound line, it will still function. But when the drawdown gets down to about 70 pounds, you've got 200 pounds between the inlet and outlet differential. The machine will start to stall. The air pressure can't create the force to transfer the gas at that compression ratio anymore. At that point, we make our midstream machine. This machine has a 500-pound differential, and then our T machine for transmission lines goes clear on up to class 600 rated systems. So you can pull that line from 1480 all the way down. The time that it takes for these different machines to transfer the gas, as with everything, it depends, but the basic tenet is your D model has a much higher flow rate. In exchange, it can't make as much differential pressure. The M is a trade-off to have a slightly lower flow rate, but 2.5 times the differential. And then the T machine, again, is a lower flow rate, but it can make 3 times the differential of the M unit. So when we go to look at projects, a lot of times what we're looking at is how many machines should we bring, in what style, in what configuration, in order to make the transfer happen in the amount of time that the project schedule dictates. So this is a picture of a job site where our client told us we will turn over the line, we'll isolate at 6 p.m. and we don't actually need the line to be completely drawn down until 6 in the morning the next morning. So there's about a 12-hour window to pump out this line. And from that information, we can say, okay, in order to do that for this many miles of this pipe at this diameter and this pressure, we're going to bring 2 twin machines, the air compressors that are driving them, and we'll go do this job as an overnight project. In this case, this was in downtown San Diego. As in most of your urban environments, traffic control and footprint is really important. This project consumed about 4 parking spots. We were drawing down 1.6 miles of 16-inch pipe. We actually finished this around 3 in the morning, so they were good to go at 6. In this case, the line was started at around 60 pounds. And we drew it down to 3 pounds and then held there. And the reason in this case that we stopped at 3 pounds was
unknown participant is now joining.
Was to account for the fact that we had unknown temperature change coming the next day, and no one wanted to be sitting right at 0 and then shutting in at 0 in case it got cold. They didn't want to end up with a negative pressure. So we stopped at 3 pounds, shut in there, and then the next morning they could continue the working, do the line repair. So in a project like this, we typically go through a project planning procedure in which we have our project manager go through with the operator and the contractors involved to look at what's the footprint requirement, what's the drawdown pressure that we anticipate, what connections are available. And we really walk through the entire project ahead of time to iron out what's going to be needed on site, how long everything's going to take, our contingency plans for if, for example, a valve leaks by very badly, or a stopping fitting, a line stop doesn't seat and we have blow by during the job. How is that going to be addressed? All of that we go through as part of the project planning. And then at the end, what we're able to produce is a nice little summary of that drawdown where the time and the gas savings can be shown, but also thanks to our friends at the EPA, we can equate those methane savings to how many acres of forest, 50 acres of forest that would need to be planted and grown for a year. So one of our customers, he's pretty animated. He likes to say, if you don't have enough time to ZEVAC, I hope you have enough time to get a shovel and go plant 50 acres. Those are our options. And we really like to show people something that they can equate, tangibly, that the public can make some sense of. The public doesn't know what 57,100 standard cubic feet is. It kind of sounds like a lot. I don't know. The gas company is going to say that's not a lot, but it sounds like a lot to me. What does that actually mean? And we're able to show every time you go do a drawdown, this is what it means. Another project recently completed. This one was in Canada. And again, a short piece of 12-inch, pull the pressure from the low 500s on down to under 50. This was a threshold that they had to meet a goal that was stated corporately. They had I forget if this was a 80% reduction footprint of carbon footprint. So 80%, we achieved that goal with this machine that you see here. I don't know how big these photos are, but you can see the tapping machine where this tie-in was made, and we pulled that gas out. Again, we're able to show, we can either bring this unit out and pump this gas out, or the equivalent environmental impact would be to grow 10.4 acres of forest for a year. So the social impact that you can present to the public for these projects that took from 11:30 in the morning till 1:30 in the afternoon is a big social impact. This project showed some of the scalability where running multiple machines in tandem can make, this is 3.5 miles of 24-inch from 80 to 2 pounds. Again, you can show the yield in that, what this means to the neighborhood, really impactful. So when you Google natural gas venting blowdown, what you get back is what the public sees. The public is not a knowledgeable gas operator that understands this is necessary activity to manage the integrity of the system and keep things in working order. What they know is this compressor station is 2,000 feet from my house. We need the governor to stop all natural gas development. Right, so they equate blowdowns they can see and smell with the natural gas industry, and the negative news cycle that blowdowns causes hurts us all. So when one person blows down, it gives fuel to this argument that natural gas is bad. And at the same time, we're putting out all these public statements, right? We're making emissions goals. We're stating net zero carbon. We're stating all these big, ambitious goals. But what the public sees us do is you vented this thing right behind my house. I don't believe you, right? It's hard to sell this message, even internally to your own workers, your own workforce, to get buy-in when you say something like this, and then you turn around and say, by the way, I need you to go vent this meter, swap this out, purge it back in. That's a really hard thing when you're trying to make your company culture to be emissions minded. The same way, for the last 50 years, the safety mindset is ingrained in every company, in every person going to work. They have safety in their mind. As this transformation is happening and we're making these announcements to get that same kind of mindset into the culture of our workforce, we have to work very hard to put those impacts in place, and it all gets undermined when you say, put all these things out, and then the other hand, out the other side of your mouth, you say, hey, so-and-so, go vent this pig trap, go run the pig. Venting is a part of my procedure that I do every day, and yet we're putting out these messages about these monster greenhouse gas reduction goals. So what we're really looking to do is provide tools to the industry to help equip the workforce to go do their job with an emissions mindset. So the ZEVAC equipment is a tool that we want the industry to embrace. It's one tool in a toolbox, but it's equipping that workforce to go forward and make these types of goals tangible to the public, so that you don't end up on YouTube blowing gas. You can put positive PR out there. So that's the very basic introduction to ZEVAC. We give this presentation every other Thursday. On the alternate Thursdays, we have a power users forum. This is targeted at folks that are really serious about taking that step toward deployment, or already have deployed equipment and want to get as much as possible out of it. Next Thursday, we'll be talking about building a business case for ZEVAC, how you can take the composite value, because the dollars that the gas is worth in a pig trap, one at a time, nothing pencils out. But it's the same as saying to yourself, I'm going to walk on the treadmill for 5 minutes and then go weigh myself. That doesn't justify buying a treadmill. Using it every day for a year, now all of a sudden I'm trim and fit, and when I step on the scale, I can see it was worth it. So building a business case next Thursday, we'll hear from some folks that have done it, have built a business case, have deployed ZEVAC, and have been successful in showing results to expand that program. On the 30th, we're going to focus in on pigging. We have a lot of folks that do pigging, both for integrity management projects, inline inspection, hydro testing, line abandonments, line repairs, things like that. But also in the wet gas gathering world, where you encounter a lot of NGLs, you encounter butane and propane, which are generally regulated under the VOC liquids rules, even though they're in a gas system. So we'll talk to some folks that pig in wet gas, talk to some folks that pig for
Kelly is now exiting.
Integrity. So I welcome you to join us for that next Thursday. For more information, we have a team of project managers that can really dive deep into target applications and the specifics of any project that you're hoping to address. We also have resources. Our YouTube channel has some other show and tell type videos, how to do ZEVAC with hot tapping, and so forth. There's also an array of technical documents that can be pulled from our website, or some of them are not the easiest thing to interpret. Compressor curves are not always instantly understandable, so we can walk through that with you with a project manager. The other thing that ends up being really important as you get closer and closer to thinking about how would this work for me is the timing. And so we have what we call the drawdown calculator, where we can feed different scenarios. My compressor station has 150,000 cubic feet in it at 800 pounds. How long is it going to take, with this machine versus 2 of this machine? What if I have to take down the suction header at the same time? So we can help go through those with you. We provide this equipment for sale. Of course, we ultimately want this to be a tool you have in your toolbox that you use every day. But we also do this for you as a service. We will come out, we will handhold and walk through the entire job, from project planning to performing the service to reporting the gas savings for you. We do it all the time. We have technicians out there doing it today all over the country. So it's a really easy way to get started, to pick a project and have us come out and do it for you. A lot of those initial projects end up being a really great show and tell. If you've built your business case, a lot of times we encourage you to invite the people who will weigh in on that business case to that job. We'll go do a real job in the field, but you can also bring the stakeholders to the site to see, for example, a lot of times somebody from safety, somebody from environmental, somebody from engineering should come to that initial job, and we can walk everyone through a project. So I'd encourage you to reach out, ZEVAC at tpemidstream.com, or you can get to us through our website, or most of you probably have my email. If not, it's Doug at tpemidstream.com. And with that, I'm going to head over to the questions and run through some of these questions. We have one, for the larger mains, we run the units in parallel. Yes. When we have large projects, miles of pipe, big inch
Unknown
pipe,
participant is now exiting.
a lot of times what we will do is connect 2, 3, 4, as many as in one job. In Atlanta a couple of years ago, 12 machines, generally with
Unknown participant is now exiting.
with the goal of meeting a timeline. So big pipe in a hurry, more cylinders pumping. Another question: restrictions for rich gas gathering with high BTU. Yeah, this is really common because of the problems with venting rich gas. Condensates, liquids, water. One of the things that's really unique about the ZEVAC being an air-powered piece of equipment is we can transfer the liquids right alongside the gas. Where a traditional reciprocating compressor, if you ever flood the compressor cylinder, I don't know if anyone has ever been around a compressor that was spinning at 1100 RPM and all of a sudden hit an incompressible fluid. It is coming apart. That machine will be destroyed. Hence, you have scrubbers and knockouts and all those things in front of your compressor skids. For us, because it's a portable tool, we will never have all those liquid stripping resources. We design the equipment to just pump the liquid right alongside the gas. In rich gas, as you draw down the segment, you will take a lot of those products to the vapor phase. So as you drop below 100 pounds, your propane is vapor. And when we discharge it back at line pressure, maybe 600, it's back to liquid. So the machines are very capable of operating in that dual compressor and pump functionality, whereas normally you don't want to run pumps because you'll cavitate, and you don't want to run a compressor because it can't take the liquids. The ZEVAC machine does both. We do this with Mark West in Ohio, very rich gas. I think they run 5 or so machines every day of the week pigging. So rich gas is definitely one of our sweet spots. Got a handful of questions here about drawdown timing, pressure, volume, transfer time. This is something that we really have to look at one at a time. We have data sheets that can give some flow rates versus differential pressures and things like that that guide it. But because of the nature of the way the machines work, they're much faster at high pressure, where every one of those strokes is very dense. And there's also no differential. So you have a trap or a segment that's being isolated at 1,200 pounds, and the rest of the line is also at 1,200. Not only is every stroke very dense, it's also no differential. So there's no load on the machine. We're just transferring it as fast as we can. So that's, and then as your segment drops, your gas that you're drawing in is less dense, and also the differential is building. So those two factors
is now exiting.
Make it hard to pin down well, it's this fast, because it changes as you go. But question here about horsepower. The unit itself is air powered, so there's not a direct horsepower rating. There's no engine. Typically, the way we look at them is what air compressors are typically paired. And your ZEVAC twin machines are generally run from a 185 CFM air compressor. That's the bumper pull, tow behind construction, very common air compressor. The twin is really paired with that for air requirement. And then our larger units, of course, step up from there. So a 375 or a 750 air compressor. Generally speaking, the more air you give the ZEVAC, the faster it pumps. So one of the things we can do to improve drawdown times is push more air. The more air it has, the faster it strokes, the faster the drawdown happens. Do we operate nationwide? Yes, we operate coast to coast from Con Edison in New York City to SoCal Gas in California, and everywhere in between, plus Canada. Lead times on call outs, it varies. It generally depends on how big of a project it is.
Is now exiting.
If we're talking about multiple air compressors, multiple ZEVAC machines, large pipe, generally we want a week or two to prep and make sure everything is good. We do a lot of projects on next day call out. We had a call from an operator of an LNG facility that had a pump seal failure, rod packing failure, needed us to install something as quickly as possible. We mobilized that day. The next morning we installed and they were back online. Can we get the service directly from ZEVAC? Yes. So TPE Midstream is the people that go to the field. A lot of times we work hand in hand with a local general contractor who's doing things like digging the ditch and welding up the tie-in that's about to happen, or there's a lot of other work typically happening. We'll usually bring 1 or 2 people to oversee the running of the equipment, but it is our people. Can you flow gas through the ZEVAC while it is off? We are looking at a purge plan to introduce into the compressor station. Yes, you can flow one direction while the machine is off. So the entire machine sort of acts like a check valve. You can free flow from suction to discharge. If you want to flow backward through the machine, we would install a bypass outside of the box to enable that function. What are some of the most unique or innovative ways customers are using a ZEVAC or building a natural gas powered versus air powered unit? I'm really glad you asked this question, Chris. We get phone calls about innovative ways to use the ZEVAC that blow my mind every day. We get questions about ammonia. We get questions about chemicals. We get questions about contaminated gas. We have gotten questions about using ZEVAC as pressure boost at the end of a distribution system on cold days. Can we boost the pressure at the edges by running ZEVAC? So we get creative uses all the time in our user training. If you buy equipment and your folks are going to operate it, we offer a pretty comprehensive training class over 2 days. We do a classroom and hands-on demo training, and then we go to the field with your operators and train them to operate the equipment. Part of that training is about, this is a tool. It's the right tool for a lot of jobs, but a circular saw can cut a pizza. It's not necessarily the right tool, but it will work. And we get a ton of those questions where people ask if this is possible, and a lot of times it is possible, but that's a different question from, is it a good idea? So we get a lot of questions where people are thinking through how to use it in different ways, and that's really encouraging to us because it shows they've accomplished that cultural transition within their workforce. They're thinking about all these different ways that they vent that we may not have even thought of. But their workforce has the mentality of, well, do I have to vent that? What else could I do? We have a huge contingent of users in the butane world where flaring, butane and propane, I should say, where flaring, particularly in the winter, is really problematic. It takes forever.
Unknown participant is now exiting.
There's a lot of safety issues with flaring rich gas and liquids. So we get some really interesting applications from those folks. The natural gas powered units, we have a few things in our R&D pipeline. The natural gas powered air compressor is something that we have found a partner who can manufacture. The driving of the ZEVAC directly from natural gas is not in our planning at the moment. Next question, are you developing a unit for inches of water? Yes, we have actually a number of things that are sort of coming later this year. One of them is sort of moving the ZEVAC toward very small distribution systems that have inches of water, or situations like from the curb tee to the meter. It might be
Chris Lanasso.
200 feet
Is now exiting.
200 feet of half inch, very small, building a very portable unit to address those situations. Inches of water for large diameter mains remain a challenge due to how close you operate to vacuum.
Jeff Kitka.
But it's something we work on every day. How large was the length? We used 12 units in Atlanta. I think that was like 17 miles of 14-inch. But the length and size of the pipe is, I think it was 1,100 pounds or 1,200 pounds.
Like,
It was
Is
more
now
the
exiting.
the amount of time that they wanted to accomplish that drawdown necessitated a pretty large a trailer. It was a gooseneck trailer with the units. Next question to get bigger flows using a lower DP. If you're blowing down and capturing from a high pressure line or system, can we regulate the pressure the ZEVAC is seeing downstream of a regulator we provide? So I think the way we typically encounter this is if you have a choice of where you're going to push the gas.
Mike, probably Mike. Yeah,
if you have a choice.
Mike, come.
Kristen, hi.
Is now exiting.
Dan.
Is now joining.
If you have a choice of where you're going to push the gas, we want to push it to the lowest pressure
Is now
system
exiting.
that you've got available. And with this, I think we're about at the end of our time. I appreciate you all joining us. What we're going to do is send out a follow-up to make sure you got what you were looking for out of this. It's a quick sort of poll, and it has some information in it that can allow us to start to engage on, how long would this take in your situation, or what kinds of applications might make sense for you. I appreciate you all joining. I hope you join us again next Thursday at the same time. We'll be doing a detailed look at how to build a business case to sell ZEVAC internal.
Is now exiting.
It'll touch on rate case. It'll touch on building a composite ROI from the safety, environmental, operational aspects.
Hong Kong.
Is now exiting.
But I really do appreciate you all taking the time to learn more about this. I hope what you take away is, if you're about to vent, pause. There are some options. Call us. We'll talk it through. So with that, I hope you all stay well, stay safe, and hopefully we'll see you next week. Thank you.
Multiple people are now exiting. 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 Multiple people are now exiting.
Paul Lutz.
Is now exiting.
Bailey.
Is now exiting.